Hello, and welcome to today's lecture on data aggregation in wireless sensor network or wireless network. So I'm Smita Rama and I'll be giving you a brief introduction and we are going to discuss the topic data aggregation. So as you all know that from our previous discussion in unit 2, which was wireless sensor network, that what is a wireless sensor network? Basically a wireless sensor network is a widely distributed sensor nodes. These are deployed in various distributed environments to measure the change in physical and environmental conditions by sensing variations in temperature, in sound pressure, in relative humidity, etc. To achieve this purpose, sensor nodes work together in a predetermined fashion to transfer the data to a main location. These locations generally refer to a sync node, or the data need to be transferred to a sync node, which is the destination through which a user can access the data. So the modern networks basically are bidirectional, making it very easy to control the sensor activity. These nodes have computational as well as communication capabilities, making them a good choice over conventional cables for operating in varied locations and in very different harsh environments. The modern nodes are very much compact, they consume very less power, and they are generally adaptive to the conditions where they are deployed in. They may be deployed underwater, they may be deployed in any mobile vehicle, they may be deployed in a particular location which is fixed, which is not movable. So they need to work accordingly to the condition or the area where they are deployed. So while we are going to study data aggregation, in the wireless sensor network, as you know, a huge amount of data is transferred from starting from the sensing node, which is the source node, which is the main sender node, by then transmitting the data to the intermediate using either multi-hop architecture or a single hop architecture, and so on transferring to the sync node. So while transferring this much huge amount of data, data aggregation technique is required to reduce the computational power and power consumption of various nodes that are part of a wireless sensor network, so that the battery lifetime of these nodes is enhanced. So basically in data aggregation, we are going to study how we can control over the consumption of the power and how we can reduce the redundancy. So let's start with the topic. Now data aggregation. Data aggregation is a process which is used to avoid the duplicacy and to save the resources. Now these resources may be the energy or the bandwidth. Now to avoid the duplication and save resources, the energy or the bandwidth type of resources, data aggregation is used. In the wireless sensor network, number of nodes collect information, and this information is transferred to the base station, which we also known as sync node, where it is processed. In doing so, high amount of battery consumption takes place. Now, whenever we are transferring a huge amount of data from one node to another, from one node to multiple other nodes, then of course the battery consumption takes place and a high level of battery consumption takes place. And at the same time, the bandwidth, the more bandwidth is also being consumed. Now to avoid this, data is processed at various nodes before giving it to the sync node. So what we do in data aggregation, we process the data at multiple levels, at multiple nodes before sending it to the main sync node or to the source node. Now this process is called data aggregation. So there are various features also of data aggregation. The first one is to increase the network lifetime. Now, of course, by performing data aggregation, we are able to increase the lifetime of our network. How? By using different resources in an eventful manner, by using different algorithms. We can remove the redundancy, we can remove the duplicity of the data, we can save the energy of our we can save the energy of our network, we can save the bandwidth of our network. The second one is using the shortest path algorithm for nearest node. By using these shortest path algorithms, we can reach the nearest node very much easily, and by reaching these nearest node using the shortest path algorithms, we can reduce the data redundance loads. So now next topic is the techniques we are going to study for performing the data aggregation. There are mainly four types of techniques which help us in achieving the data aggregation. The one is centralized approach, the second is in-network approach, the third is tree-based approach, the fourth one is cluster-based approach. In the centralized data aggregation approach, in this method, each sensory node selects the most powerful node among its neighbors and sends the data packets via the shortest possible route. Now in centralized method, what we have here, every sensory node selects the most powerful node, and this most powerful node is nothing but called the head, or it is the most nearest node which is close enough so that we can transmit the data to the neighbor. Now it selects the most powerful node among any of its neighbors, and it sends the data packets via the shortest possible route. Now this powerful node, which is commonly known as a header node, is capable of performing data aggregation, and it is capable of combining the data of various packets into a single one. What it does, it combines the multiple data into a single packet and then transfers it to the next level or the next node. These intermediate nodes can be there. There can multiple intermediate nodes, as we have studied in the clustered architecture of the wireless network. There are intermediate nodes which help for sending the data from the source node to the destination, or from any intermediate node to the destination of the same thing. So intermediate nodes are there in between any primary sensor or the header node. So this is how the centralized data aggregation structure looks like. So here, as you can see, we have these blue colored circles. They denote the sensor nodes. These are the nodes which are sensing, which are deployed in some area. Maybe these are deployed in underwater, this is deployed in your vehicle. So these these blue colored sensor nodes, they sense the data, they detect some, they read some data, and these sensor node transfer the detected data to the nearby neighbor. Now these gray colored circles, these are the intermediary nodes. These intermediary nodes act as the nodes which transfer the data from the sensor node to the main header node. Now the green colored circle is the header node. Now the main objective is to transfer the sense data using the intermediary node to the head data. Now the header node is responsible for processing the data, for combining various type of packet data into the single packet and transferring that single packet to the final node, which is the destination node. Now, this destination node is connected to the user, it is connected to the cloud from where we transfer the data. This is the objective, to transfer the data to the user or the cloud. So, the destination node, where our objective in this complete aggregation approach is to transfer the data to the destination, and it is processed using the intermediary and the header. So this is what the concept of centralized data aggregation is performed here. Why we call this approach a centralized data aggregation approach? Because here all the data is centralized at the header node through the intermediary node, and then it is transferred to the final destination. The next approach that we are going to study is the in-network approach. Now, the in-network approach is very much similar to the centralized approach. Again, there are one or more header nodes which are going to perform the aggregation work, which are going to perform the reducing the redundancy, which are going to perform the packet summary. But the variation is in this is that it is of two types. One is with size reduction, the another is without size reduction. Now, in this approach, which is very much similar to the previous one, it has two variants. One is sending the data to the source node after reducing the size of the packet, and another one is without reducing the size of the packet. In the approach having size reduction, the data received or combined from various nodes. For example, we are receiving the data from these three nodes, which is the source node. If we are collecting the data from the source node, and that data is transferred to the yellow color node, which is the intermediary node, and this intermediary node is the one who is responsible for performing the data emerging or forming the aggregation. Now what happens if we are following the approach which is having the size reduction, then in this case the sync node transfers the data to the intermediary node, and this intermediary node, the data received or combined from the various nodes is compressed using the compression algorithm or any compression method, which leads to the reduction in the power consumption involved during the transmission. Now what this intermediary node will perform, it will merge the data, and after merging, after compacting the data, it will transfer the merged or compact data or compressed data to the sync node. Another approach, another variant of this in-network data aggregation was without using any size reduction. In this method, no reduction is performed, only the data is collected from multiple source nodes, which is the blue color node, and it is transferred to the yellow color node, which is the intermediary node, and intermediary node sends the collected data without performing any compression to the sync node. This is how an in-network data aggregation is performed. Now, the third approach which we are going to discuss is the tree-based approach. Now, the tree-based approach, also called as data aggregation tree, where a data aggregation tree kind of structure is formed, and here the data is transferred in a downward to upward manner, starting from the bottommost leaves of the bottommost nodes, or which we call leaves of the tree, and up to the root or the parent. For each transmission, minimum spanning tree is created. So this is how the tree-based data aggregation structure is given. So here the blue colored nodes are the source nodes, which are called the leaves. Then we have the yellow color nodes. These are the intermediary nodes. Again, these intermediary nodes perform the data aggregation, and they collect the data from the source node and they transfer it to the root. The black colored node is the sync node. It is the root. These blue colored are the leaves. These are the intermediary nodes again, and this is the root node. The objective is sending the data from the downward to upward. So the data collected from these sync node is transferred to the forwarded to the intermediary node. Intermediary node collects the data from multiple sync nodes and the source node, and it combines the data, it aggregates, it removes the duplicity during this by performing some algorithms, and then it sends the aggregated data to the root, the black colored sync node. So the blue colored arrow you can see is the sent data, which is transferred from the source to the intermediary, and after performing the data aggregation, the red color arrow shows that the aggregated data is being transferred to the sync node. So this is how the complete transfer takes place. Here each node acts as a leaf. It sends its data to the parent node. Now the parent node is nothing but the intermediary node, now which acts as a branch node. And the data in this way flows from the leaf node to the sync. And the final parent, which is the root, does all the processing. So the next approach is the cluster-based approach. Now cluster-based approach, as we know, it is the most efficient approach in data aggregation method. In the cluster-based approach, there is nothing but it is defined as an hierarchical approach in which the whole network is separated into a cluster. It is of course, it is the most efficient approach. How? I'll just explain you why it is an efficient approach, because here the n number of nodes are there. These n number of nodes are divided into small clusters, and every cluster will have their own sync node, or in what we call is as a header node. Each cluster there will be a cluster head which will be responsible for collecting the data from multiple source nodes and transferring that data, aggregated data, to the other cluster of the destination. So the network, here we can see the network is divided into clusters containing various nodes in each. In each cluster, one node is selected as the cluster head. Now the cluster head performs the aggregation, as the cluster head uh, has a single cluster head, and every time the processing is done, every time one processing is done, the cluster is changed again by using some algorithm. We change the cluster head. Then let's see how the structure is. This is the structure of cluster-based data aggregation. Here, some set of sensor nodes are there, which is divided into a cluster. These circles represent each cluster, and every cluster is having some source node, which is nothing but a sensor node, which detects and sends the data. And each cluster is having a yellow node. It is an intermediary node, but here this intermediary node is called as a header of that particular cluster. The responsibility or the work, the role of this yellow colored cluster head is to collect the data from these nodes and to process it, to aggregate the data, and then transfer it to the sync node. Again, every cluster head needs to perform the same work and transfer the data of its all the source nodes to the destination. This is how cluster-based approach is followed. Now there is a little comparison of the various type of data aggregation approaches. So there we were having four type of approaches: the centralized, in-network, tree, and cluster. Now let's look at the first parameter, which is the delay. In the centralized approach, the delay in transferring the data in processing is moderate. It is not very much high, but it is not very much less. Also, it takes limited number of time to collect the data from multiple sync nodes and then to transfer it to the destination. The redundancy parameter, again, it is moderate. There are multiple intermediate nodes. As we remember, there are multiple intermediary nodes in centralized approach, and there are multiple sync. So we have to select one intermediary neighbor which is very much near to a particular node, and then after transferring the data from one point to another, from one node to another, we will be using multi-hop architecture here. So following this multi-hop architecture, the data is transferred from one node to the sync node, in which number of intermediary nodes are there, so that redundancy may be high in this. The accuracy again is moderate. Again, because there are number of source nodes, there are number of intermediate nodes, so the data while reaching to the sync node takes a longer period of time, takes multiple redundancy factors, and again the accuracy is not less. It is not as much high as it needs to be. So the next parameter is traffic, and next is the energy consumption. The traffic is very high, as we can see. As if you don't remember, let me just show you. This is how the centralized data aggregation approach look like. So there are multiple. So because there are multiple nodes, and there are multiple intermediary nodes, and then through these intermediary nodes, the data is being transferred to a header, and then this header is responsible for sending the data in transition. So the accuracy and so the traffic is also very high. And next is the energy consumption. Of course, because there is the network is so much spread over the area, over the environment. Of course, the energy consumption will remain high. Next is the in-network approach. The in-network approach, again, the delay is moderate, as we can see in the previous also. Again, the redundancy will be moderate because we have not taken as such any precaution. Of course, there were two variations also, by reducing the size or without reducing the size. So yes, the redundancy will be intact in this. Of course, the accuracy is very less. Now, why the accuracy is very less, I must tell you, because we are following either we can reduce the size of the packet or we cannot reduce the size of the packet. And in this case, if we are not reducing the size of the packet, the accuracy will remain very low. The traffic is high. The energy consumption here is moderate, because if we are following by reducing the in-network size reduction method, then yes, the energy consumption can be reduced. Then we have tree based. Here the delay is very less. Of course, we are following the proper channel. We are using the shortest path algorithm here. So the delay and the latency is very less. The accuracy again is moderate. The traffic will be there because there are multiple leads. There may be in the architecture I've shown you a single intermediate node, a single head node, parent node, but there may be multiple parent node as well. And again, the energy consumption is less, of course, because we are following a particular path, we are following a sequence, and the energy consumption will be low, because every time a leaf node is sending a data to the parent is performing, actually the parent is performing the data execution here. So the energy consumption will reduce as much we move towards the higher level of the tree. The last one is the cluster. Cluster, the delay is very less because we have divided the entire network into small clusters, small set of group of nodes. So the delay